Hello everyone, it's Miss Thomas, and today we're going to be looking at areas of regular polygons. Before we get started, we just need to be clear about some of the terminology we use when talking about polygons. The center of the polygon is the center of the circle that circumscribes the polygon. So basically that means, imagine that there is a circle around the vertices, touching all the vertices, so the polygon is inscribed inside of the circle. And so the center is the point which is actually the center of the circle, which leads to the radius of a polygon. The radius is the radius of the circle that circumscribes the polygon. So the radius goes from the center out to the vertice, because the vertice is on the circle, and therefore the radius goes to the circle as well. The other part of the polygon that is important is the apothem. The apothem connects the center to the middle of the side of the polygon. And so it is also the height of the triangle created by two consecutive radii. So if you imagine the second radius here, then the apothem is the height of this triangle. And so all regular polygons can be split up into n isosceles triangles, n being the number of sides of the polygon. So the central angle is the angle formed by two consecutive radii. So again, if we find the center, yikes. The central angle is this angle in here. Similarly, maybe this one will be a little less. So central angle is in the center of the polygon, and it's really that top angle of the triangle from the base. And again, n is the number of sides of the polygon. And so the measure of this central angle is going to be 360 divided by 5. So it would be 72 degrees. And then the measure of this central angle will be 360 degrees divided by 6. So it will be 60 degrees. So the area of the regular polygon, there are lots of formulas for the area of the regular polygon. At its core, I want you to understand where all these formulas come from. And what they really come from is the way that when you draw the diagonals, you end up with n, there are n congruent triangles in a regular polygon. Okay, and so we know that if we can find the area of one of these and then multiply it by n, and we can find the area of all of them, of the entire polygon. Sometimes finding the area is a little tricky though, because it is a triangle. So let's say we want to find the area of this polygon. We've got an octagon here. It's a regular octagon. And so we can see right in here that the apothem of the triangle formed by some radii is 9. So we want to do some work to figure out a little bit more about this triangle. So I'm going to draw this triangle out bigger. If we're just thinking about this triangle, we know that its height is 9 units long. and it is a right triangle. It is helpful to find the central angle. So the measure of the central angle is going to be 360 divided by 8, which is 45 degrees. So that central angle being 45 degrees is the angle up here. So this whole angle is 45 degrees. Now, make no mistake, that does not make it a 45, 45, 90 triangle, because the 90 degree, the right triangle is here, and the 45 degree angle goes across the whole thing. We do know that the apothem in a regular triangle is actually going to split these into two congruent angles. So the smaller angle will be 22.5 degrees. So I'm going to draw that half of a triangle out. So there are lots of tricks. This isn't a special right triangle, so we're not going to be able to take any shortcuts on this one. But we do know how tall the triangle is. We do know how big an angle is. And if we want to find the area of the triangle, we're going to have to go ahead and use 1/2 base times height, because we don't know consecutive sides, so we can't use that trig formula. So my area is going to be base times height over 2. Now the problem is I only know my height. So right now I don't know my base, but I know my height is 9. To find my base, which you can consider this piece your base, or the whole thing your base, but regardless, I'm going to find this side right here to help me find my base. And to do that, since I have a side and an angle, I'm looking for another side, I should be using SOHCAHTOA, my trig ratios, right? And so from this angle, B is my opposite, and 9 is my adjacent, because this is my hypotenuse. And so if I have opposite and adjacent, that's TOA. So I'm going to do tangent of 22.5 is equal to my opposite, which is my B, over my adjacent, which is that. So I know that this is going to be 9 tangent of 22.5. So there's two ways to kind of proceed from here even. I'm going to leave it like that for right now because it's the most exact. But I'm also going to keep in mind this piece right here is just from here to here. So this is 9 tangent of 22.5, and this piece is 9 tangent of 22.5. So I know, because there's two of them, that my whole base from here to here is actually going to be 2 times 9 tangent of 22.5, which is 18 tangent of 22.5. So that's the whole base of this triangle. So 18 tangent of 22.5 times 9, so this is the area of the triangle, all over 2. It's going to end up being 81 tangent of 22.5. So that's the area of the triangle. So this triangle right here, each one of these triangles made by connecting the radii, each one of them has an area of 81. Tangent of 22.5. So if I want to find the area of the polygon, of the octagon, I'm going to take 8 times the area of the smaller triangle, which is, this is where you can go ahead and change it into decimals. And that is 268. The area of the octagon is 268.41 square units.